Right, let's start with what a Lambda is. So AWS say that a Lambda is a compute service that runs your code in response to events and automatically manages the compute resources. That's what it says at this link. But what it really is it allows you to write a simple piece of code like this. We've all worked with main, haven't we? Yeah, even the Python programmers have worked with main, I think. So this is your Lambda main. It's basically a single function. The bold bits are the bits you have to have, and everything in between is just running the Lambda, and you can do almost anything in that. So a Lambda allows you to take a very simple piece of code like this and just shove it into the cloud, and within reason, not care how it runs. So you haven't got to provision. I always think of DigitalOcean, but you haven't got to provision EC2 instances. You haven't got to worry about how the networking gets to them. You haven't got to do anything like that. You just get the code, shove it in the cloud, and it runs. Again, within constraints that we'll talk about in a moment. And that's what a Lambda is. And there are lots of different things that you get, lots of different ways that you can run a Lambda. And these are just 3 of them because there are loads of them. I got picked up on this slide because there's not enough on there. So I've been asked to say these are just some of them. So you can use the AWS command line, which is what we're going to see predominantly this evening. And you can send it a message from an SQS queue. Does everybody know what a queue is? Does anybody not know? There is no shame in not knowing. Good. And you can also create a function to call one. So you can do a HTTP request to call one, which we're going to do as well later. And you can even stick API gateway on the front of that if you want to expose it to the outside world and have API keys and all sorts of other bits and pieces. OK? And they run all sorts of different languages. So I'm a big Node.js fan. TypeScript specifically, and we'll do some I'll put my ball down, haven't I? TypeScript specifically, but you can run Python, you can run Go, Java, all sorts of things, and we'll talk about some of the constraints there. And you can also run a very special Docker image that's provided by AWS. Are we all familiar with Docker? Everybody is these days, aren't they? Brilliant. So how much does it cost? So that's the best thing about a Lambda. It's an always free service. And in simple terms, you've got to call it 1 million times before it costs you any money. But there are some constraints around that. So you can call it 1 million times a month, and you mustn't use more than 400,000 gigabyte seconds. And the way these things are charged is the memory allocation, so how much memory you're using over a period of time. So if you can make your Lambda run faster, for example, by giving it more memory, then you can make it run cheaper. Okay, so a Lambda with half a gig of RAM running in 4 seconds, okay, will cost more than the same Lambda running in a gig of RAM, because in a gig of RAM it only runs for a second. Yeah, getting nods? Good, good. There are also some other restrictions. So what we're going to see tonight is that normally when you deploy a Lambda, you stick it into a zip file and you upload the zip file somewhere, and that gets loaded into the Lambda. And that zip file mustn't be bigger than 50 megabytes. When it's uncompressed, so when the archive has been uncompressed and deployed as the Lambda, it mustn't be bigger than 250 megabytes. But if you use the container image supplied by AWS, then you can have up to 10 gigabytes in your Lambda. I've no idea what anybody is going to do with that, except we tried to get Puppeteer running in a Lambda. To be fair, we tried to do it in just straight in Node. We didn't bother trying with the container image. We gave up at that point. But yeah, there are some big things that you can get, in theory, running in Lambdas. Lambdas don't run for more than 15 minutes. So if you've got a long running process, a Lambda is not the place to do it. But if you've got some small compute that can run in less than 15 minutes, ideal place for it. If you want to talk to an RDS database from a Lambda, Postgres, what have you, MySQL, what have you, then you need to use the RDS proxy, which is expensive. Because Lambdas scale brilliantly, RDS databases don't. So the RDS proxy manages the connection pools for you. Slow starts is your other problem with Lambdas. Okay, so if you've got a Node.js Lambda, you've got at least 150 milliseconds for your Lambda to get going. If you're running .NET or you've got other things that are starting up with your Lambda, it will take longer. So it may mean that your user has to wait a few seconds, a few microseconds for the Lambda to get going. Sometimes that's okay, sometimes it isn't. But what you can do is you can keep your Lambdas warm, but effectively what AWS does is it just pokes your Lambda every so often. And soon your 1 million requests start costing you money because your Lambda's being poked. So it's important to bear these things in mind. And orchestration can be complex. I was a bit blasé about how easy it is to stick the Lambda into the cloud and not worry about the networking, but it's not quite that simple. how you get the messages from these other things into the Lambda can be quite complex. But once you set it up once, it's set up and it's just repeatable and repeatable and repeatable. Yes?
Is there still a restriction on the amount of concurrent?
Oh, I can't remember. Do you remember the slide that said I'm not an expert? I can't remember.
I think there's 1,000. Yeah, I think there's like an account limit we can probably apply to if we slightly really want.
Yes, you're right. So has anyone come across these financial apps Snoop? No. So I worked there a few years ago, and yes, they had exactly that problem, and that's exactly what they did. Is the noise cancelling quite good on the microphone?
It should be fine.
Excellent. I was on a call earlier in the hotel room, and Charlotte started boiling the kettle, and I couldn't hear a bloody thing. Right. So when should you use a service? So, for example, something running in Kubernetes, something running on EC2, when should you use Lambda? So usually I say, if you need something that's on all the time, so you don't need that, so you can't deal with that cold start user service. If you're using something like Express.js compared to what you're doing in the Lambda, there's more code to maintain, and there are normally more packages to update. And one service can do lots of things. So you might have a single entity being dealt with by a Lambda, but as soon as you've got 2 entities or 3 entities, then you probably want to go for a service because the routing gets that much more complicated in the Lambda. Having said that, in the last week I've been playing with running Next.js in a Lambda, which obviously does lots of complex routing, relatively complex routing, so it can be done. The good thing about a Lambda is it runs on demand, and if you're a cheapskate like me, you don't want to be paying for a service running all of the time, especially if it's a hobby project. So a Lambda is ideal for that. There's less code to maintain because, as I've said, you've just got your entry point and then the rest happens. And multiple things normally means multiple Lambdas. As I said before, if you've got more than one entity, you probably don't want to be using a Lambda. So what we're going to do is we are going to build a very simple Lambda and we're going to stick it in the cloud. Do we think we can do this?
Yeah.
Good. Was Bob the builder on one of my earlier slides?
Yes, it was.
So that was a reminder for me to say that when you see Bob the Builder, it's time for our audience participation, and we're going to see Bob the Builder in a minute. I'm glad you're excited. There you go. Right, so what we're going to do is we're going to stick this in the cloud. What's my next slide? Oh, that's my next slide. Right, so what I want to start off by doing, a bit like a magician, is showing you that there is nothing, in AWS already. So if you look at my S3 buckets, there's none of them.
Completely empty AWS. So, do you mind making the zoom a bit?
No, I don't mind. It's remembering how to do it. There we go. There we go. How about that? Now, is that going to do all of my tabs? I bet it isn't. Oh, it is. That's good. Right. So, and I'm going to show you how logging works as well. So there's no log groups, there's no S3 buckets, and there are no Lambdas. So what we're going to do in a minute, as I said, is we're going to create a simple Lambda. We're going to zip it up, stick it in an S3 bucket, and then deploy it as a Lambda, and then we're going to call it. And the way we're going to do this is with Terraform. Terraform user? No? Yeah.
Well, mine was made in VM, so it's like...
Oh, is it? Oh, okay, cool.
I'm not really like that.
Cool. So we're going to use Terraform. Who isn't familiar with Terraform? Again, no shame if you don't know. Fabulous. Right, so Terraform is an infrastructure as a code tool. So basically imagine that you create some code which describes the hardware that you want, the services that you want. You feed it to Terraform. Terraform looks at what you've got, compares it to what you want, and builds it so that what you've got matches what you want. Okay, I'll show you that a little bit in the morning. I've got some unsure faces. No, we're all good. Okay, cool. So we'll show you how to do that. I'll show you how to do that in a minute. Right, are you ready? Yes. Amazing, amazing. Right, so I meant to say at the beginning, I've given this talk a few times, and not once have I got it right all the way through. So let's see how far we get. So what we're going to do is we're going to start with creating the zip file. So if we have a look at my, sorry for those of you that don't like JavaScript, I'm afraid all of the examples are going to be in JavaScript or TypeScript. So this is very similar to the piece of code I showed you on the slide. The thing that's in here that isn't on the slide is that console.log event, because we want to be able to see that our Lambda has run and see how logs work. So we're just going to take the message, which is sent in as the event there, and we're going to log it out to CloudFront. And then we've got a very simple response. We're returning a status code of 200, which you don't really need, but I'm doing it for fun. And then we're going to stringify the event and send it back. Yeah, fairly straightforward. And in order to do that, we need to put that into a zip file. So I've got some instructions. So first we start off with a zip file. Now you'll also notice that the index.js is in a dist folder. That is so that later on when we move to TypeScript, it matches up. So what I've done now is I've created a zip file. You can see that it's here. You can see that it's here. And the next thing I'm going to do is create an S3 bucket. So this is the code for creating an S3 bucket. If you're not familiar with Terraform, basically this is saying that I want to create a resource which is an S3 bucket. I want to be able to refer to it in Terraform as from 0 to deployed, and the bucket name in AWS is going to be from 0 to deployed. And to make it nice and easy for me afterwards, when I have to clear this up and do the next one, I set force destroy to true, which means I can destroy the S3 bucket without having to empty it first. Then what we're going to do is we're going to take the artifact from my hard drive and we're going to put that into the S3 bucket. So this is an AWS S3 object. So it's an object we're sticking into our S3 bucket. I start off by saying which bucket I want to put it into. I then say the key, which is what I want to call the object once it's in the bucket, and then the source, so where the zip file is going to come from, which is just on my local drive. Now, the next bit I'm going to gloss over. So you need a role in AWS in order to run your Lambda. And Lambdas actually will run without this role. But Terraform, when you set up the Lambda itself, insists that you have a role. So I've just got a role here that will allow it to create one that we can then put into AWS. Now, and then there's also a policy. You remember I've talked a couple of times about wanting to be able to log what we're doing. So we have to give the Lambda permission. Sorry for Copilot, it gets in the way all the time, just when you don't want it to. So we're telling, we're giving permissions to the Lambda in order to be able to talk to CloudWatch so that we can write it. And then here we've got the Lambda itself. So what I'm just going to do is I'm just going to start this off because it takes a little while to run. And I'm going to explain a little bit more about what's going on with the Lambda. So this is Terraform saying that we want to create a Lambda in AWS. We're saying where the archive is, so it's in this S3 bucket, and this is the key. We want to call the Lambda from 0 to deployed. We're specifying the role that I talked about briefly just now. We're telling it where to find the code to run in the archive. So if you remember, it was in a dist folder, and there's a file called index and then a function name called handler. So that's the convention for that. I've set publish to true so that when I create all of this, and oops, I'm just going to put yes. So when I create all of this, it doesn't just put the archive into the bucket and create the Lambda and not deploy it. The publish equals true makes sure that it gets deployed there and then. And then the runtime is Node. Our code's written in JavaScript, so running it in Node. The architecture for the Lambda is ARM64, so that's ARM64. By default, it runs as Lambda. These are cheaper. I've converted a few Lambdas from Intel to ARM64, and they've all just run.
I was going to ask why you chose ARM64, but it makes perfect sense. But
My previous comment about being a cheapskate, yeah, it's cheaper. And then layers. So if you've got some shared libraries that you want to share across multiple Lambdas, then you can specify them in the layers, but we're not doing that. Right, so Terraform has run, which means it's added five services, 5 resources. So the S3 bucket, the bit in the S3 bucket, 2 roles, and the Lambda is 5. So it's created that now. And if we go back and have a look at...
quick back over here. So when you said it's deployed the Lambda now already, it's possible for that.
Yes.
And what did it take for like its memory thing?
Whatever the defaults are. Yeah. This hasn't... So I've done this presentation lots of times, a few times, and it hasn't cost me anything yet. I haven't done it a million times, mine, but you know.
Well, if you wanted to, you could specify that thing in detail.
Yeah, you can specify all of. Yeah, there's loads of stuff that you can specify, including the limits that Alex was talking about before you get up to the account limit and that sort of thing as well. Yeah. So if we look in here now, you'll see that I have got an S3 bucket called from 0 to deployed, and inside my S3 bucket, I've got our zip file. I'm not going to try and open it because all that would do is download it again, but trust me, the code's in there. And in the function, I've got my Lambda as well. And you will see that the code is there. Someone was excited. I love that. Is anybody else excited? Hey.
Just trying to hype you up.
Thank you. I need it. Right, so our Lambda's there as far as we can tell. So let's go and see if we can call it, shall we? So if I go back to my trusty README file, I have down here a payload and a way to invoke the Lambda. So the payload is just some JSON. So do you remember our Lambda is going to take whatever we send it, stringify it, and send it back to us. So I've got a payload file here that's got that in it. And then I've got the command line here. And AWS, they don't like to make things easy, so it's a bit obtuse. But basically, what it's saying is that it wants to invoke a function. It wants the name of the function. It wants to know what to pass into it, so that's the payload. It wants to know how you want the data back and how you want to send the data. It puts it into the response.json file that you can see there almost before the end. And because it doesn't do anything sensible, like print out the response for you, we have to do more on the response. Okay, so what are we expecting?
Lots of JSON.
Sorry? Lots of JSON? I wouldn't call it a lot of JSON. But you can see there that we've got the response from the Lambda itself, and then you've got our body at the bottom here.
JSON in JSON. That's what we like.
Yes. Well, it's a string of JSON in JSON, though, isn't it? So the purists are going to get all upset because it's a string and not an object. But yeah, absolutely. Cool. Sorry, I didn't mean to blow you out of the water there. Quite my intention.
Quotes, that's what makes it cool.
Right, just to prove that I haven't made this up, that it isn't smoke and mirrors, I can change the response. Sorry, I can change the payload. And I can, and then it shows that the response has changed as well. I don't think it was. I look every time to see the cold start, and I never get it. So perhaps I just can't tell what 150 milliseconds is. I'm not sure.
It's not very long time.
I'm not sure. No. We've got some payment stuff running in Lambdas. Sorry, Alex, not your payment stuff. We've got some payment stuff running in Lambdas, and we don't see a problem with it.
But I've seen it run Lambdas in Java. That really takes a long time, or at least used to. It might be better now.
So, yeah, Node going at its normal pace is a lot quicker than Java, unfortunately. Right, yeah, so we've got a Lambda that runs, and let's see what my next slide is. So that's where when I did this presentation in two halves, that's where the first half finishes. Do you want an interval?
What?
Do you want an interval?
If you want an interval.
I'm easy. Anyone want an interval?
If you want to ask like some
No.
questions right now, based
Yeah, that's fine too.
What's the advantage of Terraform over like using CDK?
Personal choice. So I use Terraform because that's the first thing I used. The advantage for me is sometimes I don't always have things in AWS. I sometimes have things in DigitalOcean in other places, and I can put it all in one go. Whereas if you use a proprietary one, you're wedded to whatever it is they give you. Yeah, personal choice.
I'm assuming that the AWS flatline thing there was because you don't actually have an endpoint gateway type thing.
Coming later. It's coming later. It's coming later. Yeah. God dear. Can't have spoil. Yeah, exactly. Right. Okay. So part two, the automatic and repeatable deployment process. Sorry, I'm just looking over that light, and I've remembered a story I was going to tell because Gareth said I could swear. So in 1995, which was before some of you were born, I appreciate, I saw the Wild Hearts. Anyone know the band the Wild Hearts? No, a rock band from the mid-90s in a little pub in Norwich, and he was bathed in blue. And halfway through the gig, he said, "You see that light up there? I fucking hate that light. I can't see a damn thing." And this kind of reminds me of that when I glance over there. It's by the blood. Oh, I don't know where he is now.
I've seen him all the time in York.
Yeah, he's good. He played an acoustic set in Norwich a few years ago. Yeah, very good indeed. But anyway, that's by the rock music. Look it up. Sorry. Right. Okay. So the next bit, we are going to package our Lambda with something called repack, which I'll explain in a minute. We're going to upload it to S3 using the command line. We're going to publish the Lambda using the command line, and then we'll have a go at doing all of them together. Okay?
Question.
Yes.
How is that different from what you just showed?
You will see. You will see. Okay. Yes. So we did it all with Terraform, right?
Right.
But do you want to deploy your code into production every time with Terraform?
Why not?
Ah. Why not? Well, for a start, your engineers need to know Terraform, which is something I encourage anyway. Why not? That is a good question. So something else about Terraform is it takes time. It's quite slow. So some of our stuff does deploy with Terraform at Haven where we are, but most of it doesn't. So I like to think of it as a good separation of concerns between your hardware and your infrastructure and your software. Okay.
I think that's answered my question then, because if I understand right, you're talking about using the Terraform essentially to provision
Yep.
the S3 bucket and the Lambda, and then using some other tools to deploy a new version of the code.
Exactly.
into the bucket.
Exactly that. Exactly that. It's the same as creating Kubernetes cluster and some pods with Helm, and then just pushing the image every time to deploy afterwards. Everyone familiar with Kubernetes? And yeah, cool. Right. So let's have a look. So I'm going to use something called Repack, which will, I don't know how many people are familiar with the ecosystem with TypeScript, but basically one thing that you need to do is not deploy your non-production packages, so you strip your development packages. So that's something that Repack does out of the box. And then you can tell it to only zip the things that you want in your Lambda. So any peripheral stuff, like for example, the zip file that you created in the same folder that you want to upload every time you do it, and then upload the zip file and the zip file, et cetera, et cetera. So you can use this Repack and just give it the name. Again, I don't know how many people are familiar with package.json in Node, but you can get a variable that's got the name of the project, which is that first one, and then you get the version number of the project, which is that second one. So you basically get a Lambda name and a Lambda version, and as you increment your version, as you should do when you're doing releases, it automatically updates and you know which versions you've got. It also means when everything goes tits up and your infrastructure dies, when you then go back and deploy it all again, AWS can pick up the right version and get going again. Fortunately, we haven't had that happen yet, but it's always a possibility. So Repack is meant to allow you to specify just the files that you want, but I've never got that to work. So I've never got the include version of this exclude to work. So the configuration I've used is just to exclude all of the things I don't want. So the zip files, the configuration files, the license, your coverage files, all that sort of stuff. So that's in the package.json. Should we do that before I move on to the next slide?
Yes, we can.
There you go. Good man. Now, where is that? Right, that's it. Yes, of course. So I have got a TypeScript Lambda project here. I don't think I need that one again, so I'll get rid of that. I'll need that later. And in my TypeScript project, I have got some TypeScript. So there.
Do you just breathe a sigh of relief when you see that compared to the JavaScript?
Run that by me again.
colon string was the talk. That was what you were finishing.
Oh, I see.
So really guarantees that whatever people submit to that Lambda will be in that.
Hopefully. There was only one person here, I think, who was using just JavaScript. Everybody else mentioned strongly typed languages. I adore strongly typed languages. They probably don't teach you that at university, but strongly typed languages are the best. Okay? Good. Because you've got a good idea that your code is right before it gets into production rather than afterwards. So a test as well, obviously. But anyway, we'll go into test as well. Right, so I've got some some TypeScript. I tell you, this talk sometimes goes wrong. The number of times I've forgotten to rerun the build tool at this point, so the right Lambda goes into, or the right Lambda code goes in. That's the problem I make every time. And I look at the code and go, how the hell is that there? But I think I'm all right this time. But shall I just run it? Shall I just run the builds just to be on the safe side? I do need to be in the right directory. Yes, thank you. I had the right directory. Yeah, you see, no one's perfect. I'm not an expert. Right, so there you go. We've built it. And then to make life easy, I've written some scripts in the package.json so that we can do all of the stuff that I was talking about. So we've got that repack command line in the package. If anybody's not familiar with this stuff and would like me to explain more, I'm happy to do so. Okay, so that's now created our zip file, which is here. And take my word for it, it's got the built code in it. And then, oh, no, not that. And then the next bit is pushing it up to the S3 bucket. So again, AWS command line. We want to update some. No, I've gone too far, haven't I? Because I was on the right slide before. Right, again, AWS command line. Copy the package from the local machine into S3, which is basically what that's going to do. And I've got a script for that, which is npm run upload. Okay, so that's now put the archive into S3. So if I show you S3, and where has refresh gone? There it is. There's our new zip file. Okay. It's not that good, but I'm pleased you're impressed. Thank you.
Significantly bigger.
Yeah.
It's got node modules in it and all sorts of other stuff now.
Just
yeah.
all that is it for TypeScript.
Just because it's TypeScript. Yeah. Yeah.
That's the factor. Well, that was well, went from 400 bytes to 5 megabytes.
I have to admit, I haven't looked. But yeah, I can well believe that. So we've got our new archive in S3, and now we want to publish the Lambda. So again, horrible AWS command line. I want to deploy my function. That's the name of the function. I want to deploy it from this S3 bucket, and that's the key of what I want to deploy. So now I can. No, that's Teams. Don't want Teams. Now I can npm run publish. And that will publish the new code into the Lambda. So if we go to the Lambda, I didn't show you the logs earlier, did I? So if we go into the Lambda and refresh, there we've got the compiled JavaScript the compiled TypeScript. Sorry?
All 5 megabytes.
All 5 meg. Well, JavaScript isn't, but yeah. And then to make it easy to execute, I've written a script for that as well. So I can just run it and get back the body as we did before. You'll see the payload is different because as I develop this Lambda, we're going to write a reverse function, or use a reverse function which changes it. So that's the text for now. Cool. Right, any questions?
Why did you decide to switch from JavaScript to TypeScript at that point in the presentation?
To make it to make it an easy introduction, so I didn't have to explain about building TypeScript and other bits and pieces at the beginning to demonstrate just how easy it is to put some code into a Lambda.
Okay, so
is that okay?
You really wanted to be using TypeScript, but you thought starting with JavaScript because it's just an easy.
Yeah, I wanted to get you all on side that it was easy, and then show you how we could do a bit more with it.
So it sounds like the only reason anybody ever uses JavaScript.
Because it's easy.
Well, because it's the starter drug.
Yeah, it is. Yeah, I was fortunate. I never really had to do much JavaScript before I got to dive straight into TypeScript. So I've been very lucky in my career. And mind you, I did start with C++, so I've shot my foot off many times. But yeah, not with this. Right, I forgot the cards. I keep getting ahead of myself. So this is the execute function I've written. Obviously, make it so. Right, so, but we don't want to do those things, do we? We don't want to do 3 things every time we want to deploy. We just want to do 1, right? Cool. So what I'm going to do is I'm going to change the code so that we've got something slightly different in our Lambda. Now, get the right readme. Okay, so here we go. So this is the first bit of code that we're going to change. And we are going to pop it in here. I'll explain those other files later on. So what we're going to do to begin with is we're going to slightly change what we get back as a response. So we're still getting the text that we're sending in as a response, and then we're getting the same text again back as an output. And what I've done, did I show that on the slide just now? Yeah, I did. Right. So I've written a script, which I now can't find, called package, upload, and publish, which does exactly what it does on the tin. When you run that, it basically runs the other 3 scripts and uploads your Lambda. Okay, just like that. So now when I execute it, we will get the output and the text back. And if we go back to the Lambda itself, you'll see that we've got the new code. Cool. Right, next bit. No, let me put that back. But remember what I said earlier about developers being lazy and us wanting to automate stuff? Wouldn't it be even better if when you push your code into GitHub, it automatically deploys it for you? Yeah. Do we all use systems like that already? Good. Obviously, it doesn't have to be on every commit. You can have other rules for when it's deployed. But this is just an easy one for now. So what this is it's a GitHub action. Are we all familiar with GitHub and GitHub Actions? Is anybody not?
Used them, but I think I get the concept.
They're great. You really feel like an infrastructure engineer when you're playing with them because you change it, you push it, it doesn't work. You change it, you push it, it doesn't work. Yes, right. So this one is on push. So every time you push, run the GitHub action in Ubuntu, do all the normal stuff to build and install and build your node project, and then run package upload and publish afterwards to push it into AWS. Don't do this, okay? Obviously, you need to be able to access AWS, and to keep it really simple, I've put my personal keys into my GitHub repository, and I'm accessing them here. There is a way to do it with an IAM user where it's far safer, and if you're interested in that, I've got a blog post on my blog about doing it. Again, keeping it simple so that we're not blinding people with boring stuff that's really irrelevant. So, yeah, so don't do that. So what I'm going to do now is I'm going to do exactly that. And I'm going to change the code again so that we can see the change happen. Now we're actually going to reverse the code this time. Sorry, reverse the input this time. So here we are, new bit of code with the reverse function. The reverse function is very, very simple. One of the things I wanted to show you was that you're not just restricted to a single source file. Everything that you build can go into your Lambda and be deployed. And I'm then going to uncomment this code, which is the code that I've just shown you. And let's get that ready to go away. Let's get that ready to go. Oh, I better check I'm on the right branch. Yeah, well, that's one of the things that doesn't work, you see, when I push the wrong branch, but I'm on the right branch. You'll see some tests run there as well. I'll talk about those in a moment. So if I show you my GitHub Actions, there's nothing there right now. But if I push, it's deploy it's called, wasn't it? Okay, and then, excellent, go back here. In theory, in a moment, there we go, how about that? So that GitHub action is running. It's setting up the environment. It's installing the latest NPM, so it moans if you don't have the latest NPM. Then it's installing the packages. And now we're running, now it's installing the packages. And now it's running package upload and publish. So you can see it's done all that. It's now copying the archive into S3, and it's published it. And in a moment, it'll go green. So now we've got, via GitHub Actions, the Lambda updated. So I can show you that because we'll have our reverse now. And there we go, we've got our reverse function. It doesn't look so nice now, does it? Yeah. The TypeScript looks much nicer, but it's functional and it'll do. And when you start using TypeScript, there's normally so much of it, you don't want to start debugging it in the Lambda itself anyway. Right, and if I run it at the command line as well, we'll now see that it's reversed the output. Okay, cool. Any questions so far? No? Okay, cool. Right, let's call it for real, shall we? Say yes.
Okay, yes.
Right, so this diagram before, by the way, if you speak to Dom tomorrow, could you tell him that I fixed this? Because he's been nagging me and I'm refusing to fix it. Right, so what we're going to do is, nobody does this for real. Your clients, you don't send them the AWS command line and say, could you run this to get your bank account details or anything like that. So we're not going to do that anymore. We're going to put one of these functions, a HTTP function, in front of the Lambda, and then we're going to call it. So what we will do is we will add some Terraform in, which will create the Lambda function, and we'll create another bit of Terraform, which will output what the URL is going to be. And the reason you've got the angle brackets here is that's random. Okay, that bit of your Lambda, AWS generates for you. So I need AWS to. Water's going to go over before I'm finished. So we need Terraform to tell us what that's going to be. So I have to go back to the other project, and I'm going to get rid of some of these because it's back to our TypeScript. And the right README file. Right, so here we have the function URL. And what I'm going to do is I'm going to copy and paste this stuff in, and then I'm going to explain again what it does while it's running. Oh, I forgot to mention at the beginning that I'm using some remote state, Terraform Cloud, which is why you're not seeing very much happening locally, because it's all happening in the cloud. It also means we're not reliant on the speed of the internet connection here for it to run, although it does seem fine. Right, so while that's running...
Will this plot your Lambda because Terraform will try to make the buckets?
No, for two reasons. One is that this state is already remembered, so it's not run again. There's nothing in the Terraform to say to look for updates to the objects, to the zip file, and then redeploy. So...
It's just that I just thought the Lambda function was looking from a zero to deployed zip rather than from zero to deployed version.
It is, but it's already deployed, and the state I was just talking about in Terraform Cloud is maintained, and it hasn't changed, so it has no need to do anything except for these new bits which I've added.
If it was creating it would.
If it was creating it, it would, yeah.
But I mean, the point of Terraform is that it makes what's in the cloud match what you told it should be.
Yes.
Terraform says it should be a Lambda that's deployed from zero to deployed.zip.
Yeah.
From zero to deployed hyphen 1.3. So why wouldn't it change it?
Because the state that it uses to compare whether or not what you've got in AWS matches what you've got in your Terraform does match.
Yeah, Terraform's real dumb. It doesn't look at what's in AWS. It looks at what it last put in AWS.
Yes.
I know 100% that that's not true, but let's move on.
Okay. We've done the Terraform in a pretty different way.
So if that's not true, what's the state for?
The state, okay, I mean, let's not derail the thing, but the whole point of Terraform is it does notice when someone changes resources from the...
So if I went and buggered with those resources in AWS, yes, Terraform would go, you've changed it.
But I mean, that's essentially what you did with the command line, isn't it?
No, so it doesn't compare, it doesn't compare the contents of the Lambda to the contents of the zip file that it's got.
No, it just compare what bucket key you've set.
That's true.
The bucket key previously was a bucket key called from zero to deploy.zip, and you changed the bucket key
Yes.
to zero to deploy hyphen 0.1 zip.1.
That is correct.
It won't fiddle with because it doesn't do.
And I know in my mind why that isn't a problem, and you'll see in a minute it's not a problem. But
Is it because it extracts everything else?
I'm assuming so. It's not seeing a change. Yeah, no, it's all right. I enjoy the conversation, but if you're getting bored, we can move on. Should I say yes? I should have said yes before while we were talking. Right, so what we're doing is we are adding an AWS function URL, which is a HTTP endpoint, onto our Lambda. So I'm saying I want one of those, and I want it on this Lambda, and I don't want any authorization on the endpoint. Again, don't do this, because any bugger anywhere in the world can then call it. And if they want to call it a million times, however many times it is, it's going to cost you lots of money, et cetera, et cetera. So don't do that. But I'm doing it to keep things simple, because I don't want to bugger about with CloudFront and other things and API keys when I'm trying to do a simple example. And then this is an output. So it takes the function, the URL that we were talking about earlier, and it tells me what it is. And in fact, it's done that. So I've got it down here. Shall I stick it into Postman and see what happens?
Yeah.
It's like to learn that when you say, shall I do this? The answer is yes. Do it now.
Yeah. I'm not quite sure how to respond to that other than it strokes my ego and it's brilliant. Thank you.
Don't do that.
Right, okay, so Postman. Now, I've been cocky and really, really confident up to this point. Who thinks this is going to work? Can I have a show of hands?
Why not?
Who thinks it's going to work? Put your hand up.
It could work.
Right, let's see, shall we? Oh, before I forget, body that we need, is our payload there? When I practiced this on Monday, I put the wrong payload in and it didn't work twice. Oh, I've just given it away and it didn't work twice. So I've got the right payload. And it's not going to work once. You can if you wish. And it's a post because there's a payload, right? There you go, internal server error. Thank you. We're getting there. Who would like to guess or who knows why that didn't work?
502 sounds like it could work. Did it get to the clock on time?
Nope.
502. That's what it said, but maybe I'm something wrong with it.
I have to admit, I was the first time gutted that it didn't work. And I tried all sorts of different things and discovered, actually the first time I discovered I was trying to get rather than post, but so many different things. Anyway, it's by the by. So we're in the log group and we can open it up and we can see that it's run. And here is our error.
That was one of the functions.
Sorry? Oh, the error is cannot read property of undefined reading split. So if you remember, the reverse function had used split. Basically, what it's trying to split is undefined. Ah, we're getting there now, aren't we? What does it pass to handler? So if I go to the next slide. So what happens is you get different shapes of events depending on where the message is coming from in the first place, okay? So with the command line, you basically get what you give it. As soon as you move into a HTTP request, what you've got is an envelope that's got a load of other shit in it other than just that body, but the body's the only bit we're interested in. And your payload has been stringified, unfortunately, so it's no longer real Java, and popped into the body. So what I've done in one of those other files is I've written a little conversion function. So basically what it does is it looks for the body on the message, and if it finds it, it assumes it's a HTTP request. I wish there was a type-safe way to do this, and I haven't found one. So we have to just rely on the fact that it's there. And if it's that, we parse it, so it's no longer a string. We cast it, and we send it back. Okay?
I don't understand why we needed 5 megabytes of dependencies.
And if we haven't got the body, then we just assume it's the original payload and we just cast it to what we want it to be and we send it back, okay? If it comes from an SQS queue, then instead of body, you have an array of record because when you pass messages into a Lambda from an SQS queue, you can specify how many messages you want to process at one time. But the secret is always to only process one, because if you're halfway through processing 10 messages and something goes tits up, you've lost 5 messages. So we always do one at a time and scale it horizontally rather than vertically. Cool, so should we do this and see if it fixes it?
Yes, let's do it.
Right, so if I again go back to the code, and believe it or not, I've got the code ready, but it's not that bit of code. Here we go. Just get that, there we go. Did I close that? No, I didn't. Oh, I meant to also say at the beginning, I'm really grateful for you all coming out tonight, especially as you could be out there enjoying the fireworks, especially when it's so warm out there. So thank you.
It's weirdly warm today.
It is. Yeah, so here's the two-body, exactly as it was. And I don't really need to to push it into GitHub to do this. I can still use the package. Ooh, hang on. Can't do it there though, can I? I have to do it here. Let's try that again. So run package, upload, publish. And I've gone on about this a lot, but good developers are lazy developers, they automate. So with a solution like this, you can do either. You can push the code and have it deployed from GitHub, or if you keep wanting to make small changes, you can just push it locally like we have done here. Now, so that code has gone into the Lambda. I won't show you again because we know the process works. If I run execute, you'll see that we still get the same response we get back. So we've maintained that the AWS command line way of invoking the Lambda still works. And if we go back to Postman now, I hold my breath and we get our response. Okay, so it's all about making sure you've got the right message. Right, for those of you that really are getting bored, we are nearly there. So I've got a question for you. Do you want a bit more?
Sure.
Yeah? Cool. I still haven't forgiven you for the Terraform question. So, no, it's good. It's good. It's a conversation we should have because there may be something I can learn. Right, so a project that you use for a Lambda is like any other project, right? And we all know, as well as automation and other bits and pieces, we should write tests. So you can write tests in exactly the same way you would as before. So I've written a test for the AWS command line. So I'm basically putting the original payload into the handler, and this is what I'm expected to get out of it. And then I've got another test, which is for when it's a HTTP endpoint. So we've got the HTTP endpoint event, and we put that into the handler and get the same response. Okay, so you probably wouldn't want to do that. It's not a very sensible test. You'd probably want to test some of your business logic that you're actually doing in your Lambda. But this is a good example. I hope it's a good example. And then what you will see is that I have got I've got the handler test skipped because up to this point, the code that we had didn't match what we were expecting in the tests. So now if I run npm test, it will run those tests against the Lambda code. And now everything is covered as you would hope. I know a lot of us don't have this. It's sort of 80%, again, because the last 20% you're fertling around the edges of what you probably shouldn't be anyway. But at this simple stage, you've at least got that.
So just to check, you was you running tests locally?
Yeah, that's locally, just like running any other tests.
Gotcha.
Yeah. You can run tests in the cloud. You can run Lambdas locally on your machine. But the way I like to view it is once you've got the boilerplate set up, once you've got that main function and you've got the right messages coming in at the right time, okay, that's your not your standard point. That's you know that bit works. You don't mess with it after that. Everything else below that is your business logic, and it doesn't care where it's running most of the time. So. Right. So what we did was we built and deployed a real Lambda. We made it automatically deployable, and we called it for real, and we looked at some testing. Now, have I convinced you all that it's easy to get a Lambda into the cloud? Cool. I'm getting some very reluctant nods. And have I also convinced you that it's really easy to automate it?
Yes.
Good. Then my work here is done. Are there any more questions?
Now how do you debug it?
You debug it locally. So you remember what I was saying about once you've got that main function working, yeah, that's your line in the sand. Okay, everything after that is what you need to debug generally. But I have spent many times shoving console statements in different places, especially when I'm trying to get the shape of the message right, and then looking in Cloud Watch to see what's going on. And one of the awkwardest things with that is that sometimes you get JSON and sometimes you get a string of JSON, and working out which you've got and trying to see it in the Cloud Watch logs is difficult. But once you're there until someone says, oh, can we feed it from something else? And then you're back to console statements. But yeah.
Right, yeah, so essentially what you're saying with the tests is that once the input and the output is working, the code, and you work on that locally and slot it in.
Yeah.
My question. How do you get other information into your function? Say, for example, it needs to know like the name of the database or read some text file in that has to go into the output as well.
Yep.
Dependencies in general, basically.
Okay. So dependencies get zipped up. So actual dependencies, your node modules, they get zipped up and go with the Lambda, or they go into a layer and you reference it by giving it the name of the layer. If you want a database name, for example, you can set environment variables like you can with almost anything else, and then they're just there. So if you're familiar with TypeScript, env.process, is it process.env, whichever it is, then the name of the environment variable. And the nice thing with Terraform is if your database is in Terraform, you can get all of that information and just inject it straight in. Yeah, and if you've got things like text files, you can put them into S3 and you load in the AWS tools and you pull it out of S3 as you need it. Or you build it in, and then you can use the file tools to bring it in.
Don't have any sort of memory with Lambda functions, I guess. You know, like say you wanted to read a file once, and then every request that comes in, you just want to look up a variable that you had in memory and tag that on the end of your output.
So it depends. So what they do, this is getting to the edges of my knowledge now, but when you run the Lambda, it's there in memory, and AWS will reuse the same Lambda in memory over and over again until there's a gap and it stops running, which means if you bring these stuff into memory outside of that main function, they're there all the time.
So in C++, you've got static variables. What's they do in Lambda functions?
I don't know. Do we have the concept of static in the same? I don't think we have the concept of static in the same way in TypeScript. You're getting down to the language level, which is outside of what the Lambda is doing.
Yeah, certainly I've done variables that hang around.
Yeah.
It's just Lambda doesn't necessarily mean that every call is going to go to the same one. They get recycled.
Yeah.
But yeah, if you've got something slow to load, you can load it to that route and it will be there for quite a lot of
But if you've got something that's slow to load, 15-minute runtime, the Lambda might not be the right thing.
Well, I'm just thinking like, if your individual calls are quick, but they all have a sort of shared high startup overhead, but there's a way to deal with that.
Well, like I said, you can load it outside of the main function, so it's there all the time while the Lambda's hot, and you can keep the Lambda hot, but then it starts to get expensive.
I suppose at that point, it's what you said earlier, it almost ceases to be a Lambda, doesn't it? Because you're prodding it to run it.
It's suddenly feeding like a service, isn't it? Yeah.
One example is like if you've got a secret stored in the secrets manager or want to load that, there's a rate limit to that, there's a cost to it. So we do it when the Lambda does its cold starts, and then it stays hot.
Yep.
It doesn't have to do it again every time, otherwise that will be not economical at all.
Is there a way to get any awareness of whether you have cold started or whether your Lambda is currently...
Add one to your stack every time, and if it's currently 0, you cold started.
Oh, well,
Yeah, that's true. Yeah.
Resetting.
Yep.
Oh, yeah, yeah.
Interesting. Yeah.
Cool. Any more questions?
Make sure to do it atomically. Well, actually, I suppose it doesn't matter. Just get your 0 or not 0.
Just to actually call it like the economy,
Yes.
I know and I've just checked, and apparently there is a AWS extension for the VS Code.
Oh, okay.
Do you want Lambdas? I don't know. No.
No, I clearly haven't either.
Also online.
Yeah.
Yeah.
There's nothing like printf debugging, is there? It's, yeah, fantastic.
Printf's been fun for 40 years.
Yeah.
No, you know it's getting serious when you define a separate function that calls printf. So I don't want to do it anymore.
We've been in proper development for quite a while, and we've seen different deployments and productions. So this new way of deploying to a cloud and things being very automated and scriptable,
Bloody love it.
lost anything that would have been in the past. It's between this old-fashioned thing of big leap cycle, we're going to iron out all the bugs and then they'll print this to a floppy disk or CD and send it out to the customer. Like, was there anything of all these kind of processes which have been lost in modern
So comments like never underestimate the bandwidth of a man on the back of a motorbike. Those sorts of things, yeah. Oh, that's good.
The expectation that it works on day 0, that's been lost.
Do you think?
Yeah, you buy a game nowadays, expectation
Oh, I see.
is basically 0. You will have a day 0 patch.
Right, but with a game, you've got Big Bang deployment, haven't you?
Yeah.
Yeah, they don't ship it till it's ready.
I suppose the same was being like, you used to ship software with version 1, 2, 3 with like years between them.
Yeah.
Your customer would get a CD and expect that CD to basically work.
Yeah.
Whereas now it's sort of like we'll deploy 20 times a day and we'll just keep fucking with it till it does work.
Yeah. I think you're being a little unkind.
I'm being hyperbolic. But
Yeah.
It's,
So we ship to dev until it works, and then it goes to production. Cost is still a what's the word? Still a trade-off. Okay, you could still get quite a lot out of one very powerful machine sitting under your desk doing stuff, especially if you're a hobbyist. Whereas once you go into the cloud, by the time you start doing anything serious, it's a subscription every month, and it gets bigger and bigger, and it goes on and it never stops. Whereas the machine you've bought it's sit there, it's just doing stuff. So yeah, I like shiny new things as much as the next software engineer, but I really do see the benefit in this cloud stuff.
So you talked about using Terraform partly because it's a little bit cloud agnostic. Have you ever come across a cloud agnostic way of doing serverless functions that can do Lambda and or something else?
No, the ones I've looked at are all different. It's all proprietary. I mean, and the one DigitalOcean does is completely different to what you have in AWS. I'm not sure what Azure does, but it's not the same as far as I'm aware.
The other companies, well, do they have an equivalent of Lambdas or?
Yeah, so again, I don't know what they are on Azure, but DigitalOcean has things they're just called functions that go with their app platform. And basically you can do much the same as this.
You still zip up when you code or zip up messaging tools as well? Or?
I don't know. So DigitalOcean, they usually pull from GitHub, and it's been a while since I've used them. I'm going to have to say I don't know.
They're only places which they do Slalom.
Oh, okay.
Yeah. Well, like with Lambdas, you can use Docker containers.
Yeah. Yeah.
Whereas do other providers do things like that? Or
I don't know.
Yeah. I think Lambdas pretty before there's sort of cloud services that each of the providers have their own version.
Yeah.
I mean, it seems like a fairly simple thing to provide. Yeah, although I don't know about that. The bit where it's getting kind of container. There's this sort of smearing between container services and Lambda, and then it gradually can't get closer to each other.
Yeah.
It's actually behind the veil. It's actually all the same product.
Yeah,
It's from
yeah,
brand.
it's actually very well. Yeah, so big. Yeah.
It's just a container and zip to zip for running.
Yeah. Are you ensure that the zipped code that we sign off from dev is the same code?
So, well, do you know the answer to this question already? Because I know how you. Okay. So we push the zip to one place, and then we use Terraform to deploy it to dev. And then when we're ready, we put the same version number that we have in dev into our Terraform for production and run it in production. For Lambdas, for our Kubernetes stuff, we don't do Terraform, we use other stuff.
And how do you deal with the switch over period? Do you do a full deployment and then switch everyone over at once to a new version?
We don't blue-green with our Lambdas because we haven't needed to up to this point, but I believe you can.
So when you say you don't blue-green, does that mean that you have a small downtime when you're deploying?
No, not with the Lambda. So the Lambda gets deployed, and I think it just gets called the next time there's a request.
That's why you may still have an overlap. You may still have an overlap if there's Lambdas that are running profiles.
Yeah.
That's depending on.
Yeah. Again, I don't know the details, but you'd have thought perhaps they tear down the old ones when they know there's a new one. I don't know. I'd have to look. But we've not seen a problem, and all of our emails, which is millions of them a day, are sent through a Lambda, and we don't see a problem during updates.
So, obviously, we're talking about the zip deployment. You've done anything with the container?
No. I don't know how that works, but yeah. So we were trying to put this puppet into a Lambda so that we could generate PDFs, and by the time we'd run out of space, it was just easier to switch to a service and to try and start messing about with images.
You mentioned email. That's an interesting use case. Because email is almost all the way. You don't really necessarily. It's not instantaneous to send it, but from the point of view of application, you want to go, right, need to send an email. I don't worry about this anymore. I'm going to continue.
Which is exactly why we did it. So how it works, so there are two mechanisms. Most of our services put a message on a queue, that describe the email, fire and forget. We were led to believe during the development that some emails would need to go quickly, like password resets and what have you. So there's also a function a HTTP function that we can call as well on the same Lambda. And yeah, we do handle the error responses in two different ways. But yeah, so when you want fire and forget, you've got it. And when you want to know that it's gone or gone quickly, you've got that. But the Lambda just sits in the middle, and we've got a system called Bloomreach. I don't know if some of you've come across that, but that's how we send our emails. So the Lambda just sits in the middle, taking the messages and the HTTP calls and passing them on. Business decisions, so that we get all sorts of tracking and other bits and pieces with them. Yeah, not to mention all the spam you have to go through. Yeah.
This is getting a bit far away from Lambdas, but I'm interested, since you mentioned putting these requests into a queue for sending emails. How do you then deal with the potential failed ones, or ones that need a retry or something?
So there's a retry mechanism within the Lambda itself. And when it's a permanent failure, we then stick it onto an SNS topic, and the service can route. It can route from the SNS topic into the necessary queues and listen to the results. But the reason I'm smiling is because without fail, not one of our team leads, and I'm not getting it, Alex, not one of our team leads cares about email failures. Yeah, if it goes missing, they don't care. They don't even know. So it's not until someone complains. I didn't mention all that before, did I? Good. No, until someone complains, nothing's done about it.
So there's another question. Observability. How can you presumably at any given time have potentially thousands of these things running? What kind of tools and techniques have you found best for?
They're integrated with Datadog, so we can set up various monitors and dashboards and what have you.
So is that something that AWS does automatically? Do you have to do some work?
So it automatically goes into CloudWatch, and then there are various things you configure with CloudWatch to get it out into Datadog, or Sumo Logic, or whatever.
Do you find that Lambda functions are as easy to monitor as traditional server-based apps?
Yeah, I mean, you saw how simple it is in CloudWatch. You've normally got the start and the end instance with an identifier, so you know which is which. Yeah, fairly straightforward. Haven't seen any problems as yet.
Yeah, you can do stuff. It makes it like you're writing for every request you make to add these ways of making that command. Everyone wants to stitch it back together. We've actually had one of those problems. We've had the thing going so many times that the cost of the start and end was going to Datadog, which was something that we were trying to avoid. So it's a way of making not log unless something's going on.
So we have exactly the same problem, but we don't seem to care about the cost. So in production, literally all of our logs are the start and the end, unless something goes wrong.
There's a question like cost optimization. So I know like the Lambda optimizer, which is that whole time versus memory trade-off.
Yeah.
But do you ever have situations where you just want to fuse Lambdas together because they are like mutually exclusive on how hot they are? So like they'll in one Lambda, then the other, and the Lambda, the Lambda. So you've got like these cold spots for you.
Oh, see. Yes. So again, not Alex's payment provider, but we developed a new payment provider recently, and it was originally in several Lambdas, but because we had the cold start each time, as it was flip-flopping between them, they've all gone into one. Yep. Cool. Any more? So thank you. I've really enjoyed. I've thoroughly enjoyed this. I've not had this much feedback and this much playing along the whole time I've been doing this. I reckon it's because my colleagues are a grumpy bunch on Teams. But yes, thank you very much, and I appreciate you coming out to hear me. Thank you.